Yes, hello Philip. Hello everybody, and thank you for all your questions. So we have many questions, many interesting questions, of course. So the first one would be, you mentioned that finding the bottleneck in production is easy, but for projects, it isn't. What makes it difficult in projects? Can you elaborate on that, please?
The discrepancies in capacities in projects environments are much more extraordinary than in production. I repeat, in the production world, right, we have some numbers. I criticized them and said that, you know, they're nearly all wrong, but they're not, you know, out by a factor of 10, right? There are numbers around, right? That's the first point. Two, in a production environment, you can actually quite easily see if a machine is not working. Okay, in a project environment, it is very difficult to see if somebody is not working and is faking work, right? A machine will have to make noise, you'll have to drill holes and make a noise, right? Somebody sitting in his desk, you don't know if he's actually creating value or not. He looks busy, right? So anybody who pretends that they can judge the efficiency of their project environment with people being creative and doing things, I challenge them to say that's not true. It's so hard to work out, looking with your eyes, if this all makes sense, okay? So you won't see inactivity, okay? Furthermore, everybody can very, very easily make themselves into a constraint, make themselves into a bottleneck. And in fact, they do, all of them, to look busy. What do? They do multitasking, right? And you've probably seen in some of our other videos, we find it's a strange reality that people in project environments, desk jobs, doing designs and all that sort of stuff, tend to switch about 70 times a day for about a 5-minute average length of task. They just get to a certain level of madness, not further, because otherwise it would just look stupid, right? I mean, you don't switch twice a second from between emails and phone, right? It would be hard to do, but you do love doing it every 5 minutes. Right? And when you do it 5 minutes at a time, you can destroy your efficiency by a factor of 10. Okay, so what should have taken an hour, you do in multitasking, it takes all day. Okay, so the flow, the looking at capacities and looking at how busy people are, it gets to be complicated. Okay, the other thing is that for a number of reasons, project portfolios tend to be overfull by extraordinary proportions. We'll find 10 times too many projects in a portfolio, right? Because frustrated that, you know, all projects fail unless you're using a critical chain, they take a long time and stuff. They've gone down a vicious circle and saying, I'm just going to put more and more pressure. The more projects I launch, the more is going to come out, you know, hydraulic pressure. And the result of all that is this, it leads to a level of madness and that is significant. All right, as far as I'm concerned, the parts of the companies that are suffering the most now, or at least before the pandemic, were people in development of new products, right? Because the pressure was huge there. Madness was all over the place, and you'll find piles of stuff. Even on non-bottlenecks, right? Because they, to keep themselves busy, they're fully into multitasking mode. Okay, so that's why it gets more complicated. Added to the fact that you have to, in one way or another, you have to visualize the flow and see where the items are waiting, and if it's in computers, you have to spend a little bit of time working out how many items in front of this person or not. If it's piles of paper, well, watch out. In a well-known case of our company, in a beautiful company, world leader and everything, in one of their organizations, we found a pile of paper this big. Okay, that pile of paper was 5 months of work, and that showed within a 15-month process, 5 months was just one pile of paper on one desk. Okay. So you've got to be more alert because it's less physical. Everybody looks busy. It's a madhouse, and that's why it's more difficult. And when I say it's more difficult, I meant for inexperienced people, I guess myself, my colleagues, Etienne, we're all pretty happy about how we get it done. But you have to keep your feet on the ground and not get too confused by a lot of Oscar-winning complaints, right? It is certainly not the person who complains the most. Oh, in my department, I need 25 people and so forth and so forth. We're overworked. That he just deserves an Oscar. He's not the capacity constraint, right? So you don't have much data. You've got lots of people talking, and that's why it's more difficult than the shop floor where just you count the sheets of metal. Does that make sense?
Okay, so we have many other questions. For example, in Lean, the suggestion is to walk the process from end to front. Is it the same with theory of constraints?
I think that there are various recommendations on which when you walk up or down the process in Lean. I personally, I nearly always do it from beginning to end, simply because as I'm a horrible visiting consultant, I have to understand the business, right? And it's easier to understand the business if you see the process from the beginning to the end. So our experience is nearly always to do it that way. Clearly, what we do is if on going down the process we don't find it, then we go back up. As a second pass, we'll certainly be going back up, because as I explained in one of the steel sheets guy, if you go back up looking for shortages, then you're also going to get an idea of where your constraints are, right? So you go down the process looking for queues, and you go back looking for where the where the inventory appears, but also what alarms are being given about recurring shortages. So, as I say, there's nothing. I don't see anything wrong with doing it from beginning to end. It's probably just a fact of life of people like me that when I'm doing these diagnostics, I'm also learning what the process of a company is, and it's difficult to understand if you start from the end.
Okay. And then how do you ensure the bottleneck you find in the short amount of time is just not temporary and is truly the main bottleneck?
It's a good point. It's the size of the queue, which is already normally the indication. I repeat, people say that it's not true, but we do it. We've done it so many times, and it is true. There is a much larger queue than all the others, and so we find that one. And if that is not self-evident, if not, people are not completely convinced by that, we can do some data analysis. When I said I don't do data analysis, we don't do data analysis on capacities, right? We don't ask what the computer thought the workload was here and here, because that's not accurate enough. But we can do a data analysis of the queues, right? So if we have, it's happened on Monday, we've got a photo, we took a photo of today, and there was a big queue, and people started saying, yes, but it's different from one week to another. So we got with the computer, we just asked for the same photo of the queues 1 week before, 2 weeks before, 3 weeks before, and 4 weeks before. We looked, and indeed there were waves of work throughout the factory, but at that particular spot, it never got very low, right? The size of the queue went up and down, but it never went to zero. Whereas in other areas it got very low. Okay, so it's not, but it's behind the waves of work of wandering bottlenecks. It is there, that structural bottleneck. Think back to when you were nodding your head at the beginning when I was saying it's not possible to distribute the work equitably, please. It's there, you know it's there, and you're hunting you're hunting down the wandering bottlenecks, and that's not the problem. Of course, it is a problem, and you need to get rid of these waves of work, right? You're looking for flow, whether you're doing lean or whether you're doing theory of constraint. I'm not saying waves of work are a good thing, but the waves of work are hiding your structural bottleneck. That's the main message. Look behind those waves, and you'll find it.
Okay, thank you, Philip.
You know what that is, Etienne?
Have you used this system in aircraft maintenance? And if so, can you gain the same results as in production?
No, better. Yeah. Until this little pandemic came around, 40% of our business was in aeronautics. Now 0. And that business, it was developing planes, building planes, and maintaining planes. You'll see videos of that on our website. We've done it in particular for Embraer and ABS jets, and two other big clients I can't talk about. One of them being the largest in the world in maintenance of planes. So yes, it works well, but you use critical chain project management for the actual activity. If you're talking about things like check Cs or well, anything above a check A to C, you treat it as a project, and you get results. The results that you'll see on our website is basically quite easily going twice as fast, dividing the turnaround times by 2. Whatever the kind of object, whether it's a business jet, an Airbus 380 or whatever, those are the results we're getting. Us or others who do that sort of thing. And so that's a lot of money because the mobilization costs a lot. But it's also quite spectacular on the productivity of the labor, where we've got 30, 40, in one case 70% increase in productivity, right? Reduction in the number of hours required to do a check seat, because there was a lot less waiting, walking around, whatever. That wasn't just theory constraints, it was a mixture of theory constraints and lean, because all we do is always a mixture of theory constraints and lean, right? So there was by the right cocktail, theory constraints and lean. Yes, it's applied to MRO in aeronautics in general, whether it be helicopters or planes, or other MRO, by the way, trains as well. And the results are just spectacular.
Okay. I did not understand the full kit statement. Please clarify.
Full kit and fully full kit. To assemble something, right? There's a list of the things you need for that assembly, which will come from your bill of materials, right? To assemble this, you need the front, you need the back, you need the engine, you need the whatever, right? These are the things you have to assemble. Okay. The full kitting is not to try and start that assembly until you have all the parts sitting there and you're certain there's nothing missing, right? That is full kitting. And it's regrettable that in 2020 we still make a lot of money, stupidly, because people don't do that. And so they start partial assemblies, and very soon they come to us and say, it's a mess. Indeed, we have a capacity constraint, which is the square meters of our assembly stations. You go to their assembly stations and you see that it's full of half-finished assemblies and that sort of stuff. It just leads everybody completely mad. It's dangerous, it's bad for quality and whatever. So just only start any assembly operation when you're absolutely sure you have all the parts, okay? If you do not do that, if you start cheating with that, if you put your finger in the exceptions, you will rapidly get dragged into madness. That's what full kit is all about.
Do you use any process simulation software like Simulate to find bottlenecks?
No. All the data is wrong. I'm sorry. That's why I'm not very convinced by big data.
And those value stream mapping, VSM, contributes to bottleneck identification?
I prefer what I've described, which is looking for cues. There's nothing wrong with VSM, but VSM, you're going to have to choose a product to do it on, so you have to get the right product. It has to be representative, right? You're only finding the slowest resource within a VSM, and you could, if you choose the product in which you're doing the VSM wrong, it will say that the slowest resource in that VSM is this resource, when in fact the sum of all your VSMs, the sum of what you have to do, leads to an overloaded resource elsewhere. Okay, so where we don't get me wrong, we love VSMs, we do VSMs all the time, but it's not the best tool to find a bottleneck.
Okay. In a continuous process industry, like an oil refinery, units run at full capacity and have some limited spare capacity. It is the unexpected breakdown of equipment that seemingly becomes the bottleneck. Is breakdown a valid constraint?
No. Absolutely continuous processes like the one we're describing are not a world apart, but they're special. Okay, because so much is physically constrained. You can only have so much inventory at such a spot because the tank only has 500 liters here and whatever. Okay, so the level of constraint in the system in terms of the quantity of work in progress and so forth is defined by the process itself. So it's kind of a special. Okay, and in fact, that factory will be efficient or inefficient essentially the day you design it. And if you design it right, thinking about flow right from the start, and try to be imaginative about what problems are going to be in the future for that process, then you're going to get something good. If you try to if it was badly designed, you're going to have to live with it for a long while, and it's going to be a nightmare to manage with problems happening all over the place. The diagram I showed about choosing your best constraint and surrounding it by non-constraints, I think that is absolutely how one should go about designing a chemical process or a continuous process. And in many ways, that's nothing new, because you'll see several books by experts about designs of those sorts of factories that say that, right? You have to organize a certain amount of excess capacity. And also in chemical processes, you might have technological reasons that have to be taken into account, processes that can't stop, right? Because it's a chemical reaction. It must just never stop, in which case, since it must never stop, that's going to be the good reason for it to be the constraint, because you can't turn it off, right? If it was a non-constraint that you can't turn off, you're in trouble. So those environments, I don't like saying this because I think there are a number of generic rules, but those environments do bring specific problems of their own that you have to take into account when you're doing this. I repeat, it depends which, but quite a few of these processes, whether it's chemicals, whether it's biological transformations or whatever, there are quite a few areas where the process is either fragile or should not or cannot be stopped. And that will lead to a different decision about distribution of capacities, right? Because for that never to stop, you must have excess capacity before and after it to make sure that it will never be blocked by something else in the system.
All right. And in shipyard, which follows a fixed position layout, where could be the bottleneck in shipyard?
Fixed position layout. I'm afraid I'm not sure what a fixed position layout is. Great.
Okay, so maybe another question. You mentioned that assembly is seldom the constraint.
Oh, sorry. Well, I'm just trying to think of that fixed position layout. That's to say the ship stays in one place and gets worked on, right?
I think it is.
To construct. Now, I invite you to, the person who asked this question, I invite them to have a look at a webinar on, well, to study critical chain project management. And for instance, a webinar we gave, I can't remember it yet, 2 weeks, 3 weeks ago on critical chain.
Yes.
Because when you're working on a portfolio, whatever it be, in fact, you have two dimensions of constraints, right? You have capacity constraints, which is what I've been talking about today, right? Part of the organization, a department, or a certain capability has less capacity than everybody else, with the capacity constraint, okay? But then projects, individual projects, are going through the process, right? And the constraint of each project is its critical chain, or if to be very simple today, its critical path, right? And if I want to finish my project earlier, I will have to work on that sequence of tasks. Okay, so there are two dimensions of constraints in a portfolio. The one which has concerns the whole portfolio, which is a capacity constraint, and each project has a constraint. So to rephrase the question with regards to shipyards, right? Each boat being built has its critical chain or its critical path, right? And that is the constraint for making that boat, and you will need to work on that to squeeze that down to get it fast and whatever, right? But then they have all the workers in the shipyard that are working on several ships, I'm assuming in this case. And within those teams, you'll find that there are constrained resources. And indeed, in that environment, by the way, what you have to watch out for is that you might find that the capacity constraint of your system in that shipyard is not even your people or your square meters. It's a type of subcontractor, and that's not very good news because it means that the capacity constraint of your system, you don't even own it. Okay, it's a longer answer. I hope I understood the question, and I hope my longish answer was pertinent.
Okay, thank you, Philip. Where is the bottleneck in a job shop with many different orders?
It's there. I know people consider all sorts of reasons for saying I have a one-room bottleneck. Job shop is the big one. And I did leave a small margin of between 1 and 0.1%, where I said you could have environments in which you had only one-ring bottlenecks. Job shops is one of them. I oversimplified maybe when I said it never happens. Now, if we are in a situation where the changes in capacity, because we're a job shop when we're accepting all sorts of stuff, means that the bottleneck will move. It could happen. First remark, that means you haven't tried to control the kind of orders you're getting or not, right? You're accepting to live in that unstable environment. And second, I have to answer with regards to what we've been working on these past 3 years now. We haven't had too much time to talk about, which is what I call the theo constraints in services. It all started with all the work we've been doing with McDonald's in fast food. And so it's applying the theo constraints to a service industry. Okay. What is particular about that? Well, you don't want in a service industry to have a good old hard bottleneck, because a bottleneck means a queue, and a queue means a queue of people, and if they have to queue for fast food, they're going to go to the next shop, right? So how do you apply the theo constraints to something like that? What you do is you necessarily install excess capacity in a restaurant for a rush. Okay, you calculate that on average I need 25 people. That's the average. But if I look at the variations per quarter an hour, or whatever, I know that I decide I'm going to put 40 people in there, right? So there's excess, structurally, there's excess capacity in that restaurant for the 2 hours of the lunch, right? So you could say there's no bottleneck as such. But then what you do is you decide to name, you look at how the flow works, and you decide how you're going to manage it to make it robust and fast, okay? And so you choose something that is a control point, and that control point is very likely to be the bottleneck for a few minutes when there is a very high demand, right? That famous moment in a restaurant when there's a whole busload of people arrive and suddenly 30 people come through the door and you're completely overloaded, right? You've decided previously where the constraint was going to be, and you manage your flow according to that constraint, okay? And with one of those tricks that I think the theo constraint talks about better than anybody else, which is watch out. You do not start on a new order as soon as it arrives. You wait until your system is ready to do it, right? And in a restaurant, what they do, a lot of discussions before it became a new way of doing business. It's not because a customer comes in and orders his food that you start it in the kitchen, right? You start it in the kitchen when the kitchen is capable of doing it. It's got its capacity ready, and it's ready to do it right, fast, first time, right first time, and all that. Okay, so you have to limit the flow in the system. Sorry if that sounds as if I changed the subject. You get back to your job shop, right? Try and decide what the controlling point would be, okay? That will control flow, and then you can keep the flow before it and after it under control. And you will be able to manage from there. And you will, of course, not get rid of all the waves of work, but that's how we approach the job shop phenomenon. You're going to have more legitimate ways of work than other people, correct? I did say that there aren't wandering bottlenecks just because so many, 9 times or 99 times out of 100 people are talking about wandering bottlenecks when they have no decent excuse for having wandering bottlenecks. I've seen wandering bottlenecks in industries that has zero fluctuations in demand, right? It's just proof that they were driving their system mad.
All right. And from a lean perspective, shouldn't quality control be eliminated as inspection is a waste?
Yes. Yeah. Of course. Again, forgive by the nature of the format of these webinars, we talk about one particular subject. So I seem to ignore whole dimensions of the subject. Of course, one of them, W. Edwards Deming is one of my heroes. Somebody who has not been understood well enough and is not referred to enough. And everything that was said by him, done by Toyota. I mean, a number of things are extraordinary in what Toyota has managed to do over the years. And one of them is the level of quality that they've got to in their business, which is continues to be the reference. And they get there indeed, and they get to exactly what was pointed out in the question, where the quality is inbuilt into the process, and you don't have to control much. You just take a sample from time to time to be able to do your SPC and make sure everything's installed is still okay. But the process is foolproof, and you're right. But I believe that Toyota is slightly ahead of quite a few other organizations and businesses in the world. For instance, the thing you're looking at there with airplanes and stuff, or other objects. I'm still surprised how often companies tell me that they have a 10% scrap rate, or a 20% scrap rate, or a 30% scrap rate. Some of these being leaders, world leaders in technology that's been around for at least 30 years. So sorry to react in that way. You're absolutely right. It should be the obsession to make your processes completely robust. But no later than this morning, we were having a big discussion about a company that had very high levels of rework or scrap, and they completely abandoned the idea that they should get to a stage where you were talking in parts per million, right? And all that Toyota world which exists and can be applied to so many other businesses, right? It's not specific for us. It'll take time, it'll take diligence, it'll take rigor, it'll take transverse work, it'll take lots of things. One of them, which by the way, so I'll shut up. This will be my closing statement at this time, right? You're not going to get quality into your factory, right? If you don't design manufacturability into your products. This is pure lean engineering, pure Toyota product and process development system, with Alan Ward and all that stuff, right? And it's still so true that many companies, for instance, the aeronautics, since we've got a picture there, you've got these people who design the bits and pieces of an airplane, who never set foot in the factory, and put specifications on the different parts, which are going to be a complete nightmare to produce. And so part of the non-quality is trying to reach ridiculous specifications which have absolutely no reason for being there. Okay, so if you really want to get to the kinds of levels that were being mentioned, right, like the Toyota example, well, please read again The Machine That Changed the World, and read what they said about how you design products, where they try to design cars that are quite easy to build. It seems like a good idea, doesn't it? Because if you design an airplane that's impossible to build, well, it's going to be impossible to build for 25 years. It's so often like that, right? We're still alone. We've taken decades to try and get close to Toyota in the way it manages factories with SMEDs and Kanbans and this and that. Okay, we haven't even yet started on the journey of Toyota product and process development systems, and that's a pity because you need to do that if you really want to get anywhere. Okay, so sorry for that long diatribe, which will take me over the 30 minutes of questions and answers. Thank you for if you're still there, for listening in. Do join us for future webinars, or have a look at the videos, or participate in our regular training courses and stuff. Take care. I hope you're having fun. Bye.